Circles and trigonometry. In this video, we will look at the relationship between circles and trigonometry. Let's get started by looking at some terminology. To start, draw an x-axis and a y-axis. The initial arm is the ray or arm of an angle in standard position that is on the positive x-axis. All the angles that we will be using start on the x-axis. This is called the beginning location. What then is the terminal arm? The terminal arm is considered to be the ray or arm of an angle in standard position that has rotated about the origin. This arm represents the ending arm of the angle that we are representing. For our example, in our diagram, we show a rotation of 60 degrees. Note, the positive angle is a rotation counterclockwise. The negative angle, if we had been given one, would be a rotation clockwise. Working with angles in standard position. An angle in standard position will have an x component, a y component. On the terminal arm, there will be a point P with coordinates x, y, an r component, which represents the radius. Since a 90 degree is formed where the y and x meet, we can use the Pythagorean theorem to find the length of r given the values x and y. So r squared is equal to x squared plus y squared, and this will give us a point A with the value r0 along the x-axis. Now, let's take a look at a sample problem. Find the radius of the circle passing through the point 6, 8. The measure of the angle in standard position for the terminal point 6, 8. State the three primary trigonometric ratios in exact form. Remember, the word exact means no decimals, just whole numbers and square root values. How can we solve a problem using this information? For this solution, it is suggested that you do it on graph paper for accuracy. Start by making the sketch. A, start by making the x and y coordinate system. Plot the given coordinates P, 6, and 8. Start with the x at 6, y at 8, and then we will have point P with coordinates 6 and 8. Then draw the terminal arm and label it R. Add the reference angle theta. How can we solve a problem using the information continued? Here's the solution. Reminder of what our graph looks like. Using the Pythagorean theorem, find the value of r. We know that we have a right-angled triangle where the x and y meet, and that will allow us to use the Pythagorean theorem. R squared is equal to x squared plus y squared. So r is the square root of x squared plus y squared. 6 squared plus 8 squared, when we substitute in the numbers, which comes out to the square root of 100, which is 10. Now, continuing, find the measure of angle theta. You are given the x value, which is adjacent to the angle. You are given the y value, which is opposite to the angle. We know that the ratio tan theta is equal to opposite divided by adjacent. We know that opposite is your y value and your adjacent is your x value. Now, continuing on, tan of theta is opposite divided by adjacent, which is equal to y divided by x, using the variables given in the diagram shown on the left. We know that y is equal to 8, x is equal to 6, so we will substitute these values in for opposite divide by adjacent. Now we can use our calculator. Second function tan, 8 divided by 6, will give us the value in degrees of 53.1 degree. Or in radians, if you change the mode on your calculator to radians and repeat, the calculator steps equal 0.927 radians. Just to double check, if you convert 53.1 degrees by multiplying by pi over 180, we will get 0.927 radians. How can we solve the problem? Continued. We know that x is 6, y is 8, and the radius is 10. So we can now state the three primary trigonometric ratios in exact form. Sine we know is opposite over hypotenuse, which is y over r. 8 over 10 simplifies to 4 over 5. Cos theta is adjacent over hypotenuse, which is x over r, which is 6 over 10, which is then 3 over 5. Tan theta is opposite over adjacent, which is y over x, which is 8 over 6, and breaks down, or lowest terms, 4 over 3. Coming next. In this video, we saw how to apply trigonometry to the first quadrant. In the next video, which you need to take a look at to complete your assignment, you will take a look at how to apply this to the three other quadrants.